With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
A small 10-watt source of wavelength 99 Newton meter is held at a distance 0.1 meter from a metal surface. The radius of an atom of the metal is approximately 0.05 nanometer. Find the average number of photons striking an atom per second and the number of photoelectrons emitted per unit area per second if the efficiency of liberation of photoelectrons is 1%. So a small 10-watt source. Let's say this is your small 10-watt source, some form of a bulb. It is emitting, it is 10 watt, so that means it is emitting 10 joules per second. Now let's say that this energy is being absorbed in a spherical region around it. So if this spherical region is at a distance of 0.1 meters, so the energy that will be absorbed per unit area, energy absorbed per unit area, and since we are given the power, so per unit area per unit time will be equal to this power divided by the area of the surface area of the sphere, which is 4 pi r square, which is 0.1 meter. 0.1 squared is equal to 10 upon 4 pi 0.1 squared. Now it is given that the radius of an atom of the metal is approximately 0.05 nanometers. So if this is the energy absorbed per unit area per unit time, so the energy absorbed per unit time by the atom will be this multiplied by the surface area of that atom. So I'll consider this, since this atom would be on a metal, so only a circular surface of this atom will be visible. That means the area will be pi r square. So the energy absorbed per unit time is equal to 10 into 4 pi 0.1 squared into pi, and this is 0.05 nanometers, so 0.05 into 10 raised to the power minus 9 squared, which turns out to be 6.25 into 10 raised to the power minus 19 joule per second. Now this is the total energy that is being delivered to this metal surface per unit time. But since the wavelength of the source is given as 99 nanometers, so the energy of each photon will be equal to hc by lambda, which is equal to 6.6 into 10 raised to the power minus 34 into c, which is 3 into 10 raised to the power 8 upon 99 into 10 raised to the power minus 9, which is equal to 66 into 3 upon 99 into 10 raised to the power minus 34 minus 1 plus 8 plus 9. Now 6, 9, 3 and 2, which gives us 2 into 10 raised to the power, this is minus 35 plus 17, so minus 18 joules. So this is the energy of each photon, and this is the energy that is incident per unit time on the metal surface, and we have to find the number of photons the average number of photons striking an atom per second. So the average number of photons striking an atom per second will be energy incident per second divided by energy of one photon. So energy incident per second is 6.25 into 10 raised to power minus 19 joules per second, and energy of one photon is 2 into 10 raised to power minus 18 joules, which gives us 0.3125 per second. So the average number of photons that are incident on the metal is 0.3125 per second. Now, the second part of the question. The second part says that the number of photoelectrons emitted per unit area per second if the efficiency of liberation of photoelectrons is 1%. So number of photoelectrons emitted per unit area per second. So for that, what we have to do is energy incident per unit area per unit second divided by energy of one photon into the liberation efficiency, which is 1%, so into 1 by 100. Now energy incident per unit area per unit second we calculated earlier, which is this 10 upon 4 pi 0.1 squared divided 0.1 squared. So 10 upon 4 pi into 0.1 squared divided by energy of one photon, which is 2 into 10 raised to power minus 18 into 1 by 100. That gives us 10 into 10 raised to power 18 into 100 upon 8 pi into 100. This and this get cancelled. So we have 10 raised to the power 19 upon 8 pi photons per second.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.